Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on complex analysis, lecture number 14, in which I will solve more problems on analytic function. Now, we solve a problem. Problem is so that an analytic function in a domain with its derivative 0 for every point of the domain is constant. Let fz is an analytic function given that derivative of fz is 0 for all z belongs to D equal to domain. This is number 1. Since fz is written as u plus iv and derivative of fz equal to ux plus I vx. Ux is a partial derivative of u with respect to x. Vx is partial derivative of v with respect to x. This is number 2. Using 1 into, we get here derivative of fz is 0. Here we write 0 equal to ux plus ivx, equating real and imaginary parts of both sides. We get ux equal to 0 and vx equal to 0. This is number 3. Since Vx equal to minus uy implies that this Vx equal to 0, 0 equal to minus uy implies that uy equal to 0. This is number 4. Since u is the function of xy implies that du equal to partial derivative of u with respect to x dx plus partial derivative of u with respect to y dy, and this equal to ux dx plus uy dy. Here ux equal to 0, multiply dx plus uy equal to 0 multiply dy using 3 and 4. And this equal to 0. Integrating, we get u equal to a constant equal to c1. Let this number 5. Here we write this is by CR equation, Cauchy-Riemann equation. Again, by CR equation, Cauchy-Riemann equation, x equal to Vy implies that here ux equal to 0 equal to Vy using theory implies that Vy equal to 0. This is number 6. Since V is the function of xy implies that dv equal to partial derivative of v with respect to x dx plus partial derivative of v with respect to y dy. This is vx dx, this is vy dy. Vx is 0 in theory, 0 dx, Vy is 0 in 6 using theory and 6 implies that dv equal to 0. Integrating we get v equal to constant equal to C2. Let this is number 7. Since fz equal to u plus iv, u is C1 constant, C1 plus iv is C2 using 5 and 7 equal to a constant. Therefore, fz is constant. Proved. Now we solve the next problem. Next problem is show that an analytic function with constant modulus in a domain is constant. Now we solve this. Solution. Let fz be an analytic function and let fz equal to u plus iv. This is number 1. Given that modulus of fz is constant, implies that modulus of fz means square root u square plus v square equal to c. Let constant, this is constant, implies that u square plus v square equal to c square, squaring both sides. This is number 2. Differentiating both sides partially with respect to x, 2u partial derivative of u with respect to x plus 2v partial derivative of v with respect to x, and this is constant, derivative of constant is 0, implies that u, we may write this as ux plus v, we may write this vx equal to 0, dividing both sides by 2. This is number 3. Again, differentiating both sides up to partially with respect to y. We get 2u partial derivative of u with respect to y plus 2v partial derivative of v with respect to y. This is equal to 0, implies that uy plus vuy equal to 0. This is number 4. By using CR equation, Cauchy-Riemann equation in 4, we get uy equal to minus vx plus vy equal to ux. This equal to 0. This is number 5. Multiplying 3 by v and 5 by u and then subtracting, we get ux multiplying by v plus v square vx. We are multiplying by u and then subtracting, plus u square vx minus uv ux equal to 0, implies that this and this term cancel, u square plus v square under bracket and this vx equal to 0. Using 2, u square plus v square equal to c square. This is c square vx equal to 0, implies that vx equal to 0. This is number 6. Again, multiplying 3 by u and 5 by v and then adding, we get multiplying 3 by u square ux plus uv vx. Here multiplying 5 by v minus uv vx plus v square ux equal to 0. This term and this term cancel, implies that u square plus v square common ux equal to 0, implies that since u square plus v square equal to c square, multiply ux equal to 0, implies that ux equal to 0. This is number 7. Since we know that derivative of fz equal to ux plus I vx, ux is 0 from 7 and vx is 0 from 6. Using 7 and 6, implies that f dash z means derivative of fz equal to 0, integrating, we get fz equal to a constant. Proved. Now we solve the next problem. Problem is, if w equal to function of z equal to u plus iv be an analytic function of z, z equal to x plus iy, then family of curves uxy equal to c1 and vxy equal to c2 form an orthogonal system. Now we prove this. Since given that w equal to fz equal to u plus iv is an analytic function of z, where z equal to x plus iy, given that uxy equal to c1 implies that du equal to dc1 implies that partial derivative of u with respect to x dx plus partial derivative of u with respect to y dy, and this is the derivative of constant is 0, implies that del u by del x dx equal to minus del u by del y dy, implies that del u by del x by del u by del y, negative sign, equal to dy by dx. This is slope of the tangent at any point of the curve. Let this is equal to m1. Therefore, m1 equal to minus partial derivative of u with respect to x by partial derivative of u with respect to y. Let this is number 1. Again, given that v xy equal to constant c2 implies that dv equal to dc2 implies that partial derivative of v with respect to x dx plus partial derivative of v with respect to y dy and derivative of constant equal to 0. Let this is number 2. By using Cauchy-Riemann equation, since given that fz is analytic, so Cauchy-Riemann equation is applicable. Minus del u by del y, del v by del x equal to dx plus this is del u by del x dy equal to 0, implies that del u by del x dy equal to del u by del y dx. implies that dy by dx equal to del u by del y by del u by del x. This is the slope of the tangent similar to this. Implies that, let this is m2. m2 equal to del u by del y by del u by del x. m2 equal to slope of the tangent at any point of the curve. Let this is number 2. Now m1 multiply m2. m1 is minus del u by del x by del u by del y, and m2 is del u by del y by del u by del x, and this is equal to minus 1. Therefore, two curves are orthogonal because multiplication of slope of tangents to the curves equal to minus 1. Hence proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.